So next up, and last speaker for the day is Domingos de Silva Barbosa. Just before that starts, just a reminder, after this, we'll do the poster lightning session. So if you have a poster, then be prepared to give a 1-minute talk on it and come queue up after this talk finishes. I'll do another reminder at the end of this talk. But over to Domingos, who's going to talk about PASO space surveillance in a dark sky destination.
Okay, thank you. Thank you for the invitation. And I understand that I'm just the last guy and separating you from indulging in some rest and some fancy activities. So I'll try to go on. So I'm talking about PASO, it's Pampilhosa da Serra Space Observatory. So we have a small space observatory in the middle of the country dedicated to space situational awareness. And I'm talking on behalf of all these people there. Okay, just to let you know that this type of discussions was echoed actually, and some of us took the stage for the Science Summit at the General Assembly of the United Nations, and we were already discussing this, balancing the use of satellites with preserving our dark and quiet skies. I think probably Andy Williams will mention this as well. And yes, of course, we have activities in one dark sky, and dark and also quiet skies share some characteristics that are usually come in a bundle. So they are usually in pristine or low human density sites or regions. They are usually with high biodiversity or geological interesting territories. Many times they are as well, we have facilities in law enforced protected territories, and we negotiate with the owners of that land the constructions of observatories, many times in sacred land, protected indigenous territories. So they are usually part of natural assets for the benefit of humanity. So that's where we locate astronomy and space science infrastructure, the ones that are usually very competitive in terms of the world science. They promote sustainable practices, and they became a promoter of astrotourism. They also usually open new opportunities for cultural heritage and biodiversity preservations. What Matthew Isidro has talked about and commented about the efforts in South Africa and Australia, it's a good reminder of that. They also present opportunities for education, socioeconomic welfare in those regions. And of course, I think one of the things that I didn't hear during the week, but it's important to emphasize, dark skies contribute to advanced societal development goals. And this is important. So satellites, constellations importance. We have basically the major satellites parameters. So we have to divide these satellites in the usual jargon, which is geostationary, mid-orbit satellites, and low-orbit satellites. They have different types of satellites and different types of sizes as well, according to these orbits. But these satellites and these different types of constellations also have different requirements and different consequences on the ground segments. For instance, the LEO will require a very much dense ground segment to support the uplinks and downlinks and the servicing of these satellites, while usually geostationary satellites, because they have a vast coverage area, don't require that much. So there are many things as well that's going on. So where we are in terms of starlight, dark sky, Aldeias do Xixo, so it's my country on the left. So you see it's light almost all over, and we have some spot in the middle of the mountains where two ranges of mountains actually screen and shield most of the light coming from the coast, where about 80% of the population of the country lives. We are very lucky for this double type of chains, otherwise it will be a nightmare. And it became a proposal for this in 2019, and it made its way back. We collected many data, we did a lot of things, and became certified by the Starlight Foundations, and is one of the 3 dark sky, starlight dark sky destinations in my country. There were plenty of activities. You see some of those: sustainable tourism, rhythms of nature, and so on. There are a lot of cultural heritage that uses astronomical observations for their rhythms, societal rhythms, like transhumance and so on. So this is the winter solstice, for example. It's one of the typical masks they use in festivities around Christmas, so for the winter solstice, and also in Carnival. That's, by the way, how I feel sometimes when talking to some policy officers about this. And these are the folks in winter solstice going for the bonfire around Christmas evening. Anyway, so we started way back in 2011 or a little before. We had to make people proud of their observatory. We engaged with the villages. It became their thing in their land. And it was very interesting. So you see the whole folks of the villages, plus a gathering of about 50 teachers that came across many countries for a educational party. And it was inaugurated at the time, this 9-meter radio telescope. Then it followed the usual path. We aggregated things and so on. We started partnering with some people, like you know, from the SETI Institute, Frank Marchi, from Unistellar, one of the co-founders of Unistellar. These digital telescopes are excellent to provide very nice educational tools for astrotourism and so on. Actually, we made a very nice work during COVID times because digital telescopes avoid people packing, trying to see in the telescope, because social distancing meant that these types of activities were almost dead. And we thank Unistellar and the other digital telescopes to maintain this type of activities. Now, our ecosystem is about this, where we are. So we have many things. So we have, besides a small L-band radio telescope for educational purposes, the telescope that we saw, the radio telescope, was transformed into space radar. And we have a wide field optical telescope that performs every night for the European Space Surveillance and Tracking Program and provides data for space debris monitoring. And we installed last year a wide field of view twin optical sensors for LEO tracking. So just an intermezzo, which is why we are doing this, is because in 2014 in Europe, the European Union decided to aggregate several national systems and create an European, more centralized system to monitor the space junk. And this started with the 5 countries that have more mature systems: France, Italy, Spain, Germany, and the UK. Then came Brexit, UK left. Other countries like Poland, Portugal, and Romania entered, and now there is a batch that aggregates Netherlands, Finland, Sweden, and Greece, and Austria, by the way. And so it became, and most of these countries, what they provide is time slots in some observatories, plus some sensors that are dedicated full time to space surveillance and tracking of objects. The main preoccupation was about space debris, but of course there are the mega constellations and the associated stuff that goes around. So typically, the space situational awareness, space surveillance and tracking operations of our node, which is fairly similar to the other nodes, it collects data through the sensors, telescopes or radars, pass through a planning system, compares to a catalog or follows a catalog and the planning of the observations every day. And for some of the objects, assesses collision maintenance and collision risk, so it's information for the operators, and goes to the satellite center in Brussels, where they take decisions. And of course, this, in our case, is operated under contract with the Ministry of Defense. because the defenses like to filter some of the information. So information of the military fleets that shows up in this data have to be screened out, of course, and some special debris that come out are also screened out. So our system has 2 telescopes nearby here in Madeira Island. There is one in the Azores, it's not there, and there are the operation centers in the Azores and Oeiras, and the telescopes. And by the way, one of the nice things about this system is that partially, it was an interesting story. It was at least the radio telescope and the processing pipelines for the optical telescope were produced via our Engage SKA grant. So it's the grant that enabled us to aggregate critical mass to enter the SKA a few years back. So this is the survey telescope. So it's based on a RASA system. It's deployed. It can be deployed elsewhere. It was in the Azores, and now is in our space observatory, and is dedicated to GEO and MEO space debris surveys. Calibrations occur every 3 months on a selected objects by SATSEN, which usually are GPS or Galileo satellites. In the case of Europe, it must be Galileo satellites, plus a bunch of satellites whose characteristics are very well known, and they can serve as calibrators.
3 minutes.
Okay. It takes a few hundreds of images every night. Okay, we have the radar. The radar had first light last month. So it's the International Space Station being detected by the radar at 5.56 gigahertz on a military band. This is the telescope. And this is a quite fancy system, so it's a twin system on a special equatorial mount and very fast. So with the slewing speeds up to 40 degrees per second, so it can take fields very quickly in LEOs. It has light curve capabilities and filter wheels because we will be allocated about 25% of its time for science and to do whatever we want. So we can probably collaborate with CPS when it is after its first light to provide some data. It will be extremely useful because it's a 4.3 times 2.6 image that comes out of this. And of course, we did the usual stuff like reduction process, source citation, characterization, and of course, comparison to catalogs and extract information on resident space objects. So we are doing our own pipelines, which is very much similar to some of the pipelines that we saw this one. So here is one image, and you see one of the objects. So we took consecutive objects, we tried to bin, pile them up, correct for a number of things, and then extract and go to the catalogs. Strict detections, for example, this one was unexpected and is one of the satellites that we identified with the catalog after taking out the TLEs, of course, out of the SST catalog and compared, and we identified as Cosmos 682 is lost and somewhere. And these are the characteristics. And in conclusion, so we have SSA activities at the core of the dark sky destinations. On one hand, we contribute to sustainability of the Aldeias do Xisto heritage preservation through a number of things that I don't have the time to talk about. Believe me, please. and we contribute to the monitoring of space activities by being under contract with the Ministry of Defense to provide data for EU SST, and we became also involved in the space traffic management policy discussions, which is a very important thing that we should be, because STM policy discussions are just an elevation to another stage of the international maritime law to the outer space nearby us. And so these things are coalescing to probably a framework. The EU SST was just created to aggregate national sensors that are spread all over and create a more unified tool to provide data. Most of the data will be on public databases, but also it will enable Europe to have a more homogeneous answer and a framework to negotiations and collaborations with other regions, for example, with the US, China, India, and so forth, and make agreements on data sharing. Thank you.
So I think we have time for one question while people for the posters come up. Any questions? Siegfried? And people giving posters, talks, please do come up now.
Thank you for the excellent talk. Siegfried Eckel, UAUC and CPS. I was just wondering, your active radar is an asset that's really, really interesting because it's very complementary to some of the data sets that we get. Will the public data also be including the radar data, or is that something that is
Yes,
restricted?
it will be in the future. For the moment, they are just testing. We got this summer the first lights. We are on authorized military band for the moment, and that's the licensing with the spectrum regulator is provided for every 6 months. And once we do that, then my colleagues will inform Kraft and Benjamin first, and some of the data can be provided for range data. That will be very useful.
Thank you very much.